Greetings, one and all. We are pleased to present our analysis on United States military spending by year 1960 to 2020. Our team consists of three dedicated members, Vikas, Ravna, and Vinayak. The introduction slide outlines the objective of the analysis, which is to forecast the US defense budget for the next 10 years using yearly data on defense budget from 1960 to 2020. The process involves stabilizing the variance with a box-Cox transformation and utilizing BIC to select the optimal ARIMA model by balancing model complexity and goodness of fit. The aim is to provide accurate and insightful forecasts for long-term planning and decision making. We are focusing mainly on the two columns year and defense budget.
Visual analysis. The dataset is converted to a time series plot. Figure 1 shows an upward trend. The plot does not exhibit clear seasonality. Given the data is annual, seasonality is less relevant. The variance in the defense budget increases over time. There are stability, gradual increase, rapid increase, and some slight fluctuations noticeable in the behavior. There are several changed points which are visible as well. The ACF plot, figure 2, shows significant autocorrelation at several lags. The autocorrelation starts very high at lag 1 and gradually decreases, indicating a strong persistence or the trend in the data. The slow decay suggests that the series is non-stationary and has a trend component. The values beyond the 95% confidence interval, blue dashed lines, indicate significant correlations. The PACF plot, figure 3, shows significant spike at lag 1 and cuts off quickly. The partial autocorrelation is very high at lag 1, then drops to near 0 for subsequent lag, suggesting that an AR1 model might be appropriate.
Analysis after first differencing illustrates the results of applying first differencing to the defense budget time series data to achieve stationary. The time series plot figure 4 shows the difference defense budget values over time, revealing a more stable mean and reduced trend compared to the original series. The ACF figure 5 and PACF figure 6 plots are then used to identify the presence of any remaining autocorrelation. In these plots, significant spikes at lag 1 suggest potential ARIMA model that include AR or MA components. This differencing step is crucial for preparing data for accurate ARIMA modeling.
The model specification slide presents the structure and criteria used for selecting ARIMA models based on EACF table and BIC plot. The EACF table indicates different combinations of AR and MA terms leading to four candidate models: ARIMA 013, ARIMA 012, ARIMA 112, and ARIMA 113. The heat map on the right visualizes the BIC values for various models, mainly on ARIMA 114 and ARIMA 514, with darker shades indicating lower BIC values. So in total, we get 9 models given below. Residual analysis. This slide evaluates the ARIMA 110 model's adequacy by examining its residuals. The top left plot shows the time series of residuals indicating any patterns or anomalies. The ACF and PACF plots below it help check for autocorrelation in residuals where ideally no significant lag should be present. The normal QQ plot compares the distribution of residuals against a normal distribution, showing deviations from normality. The lung box test p-values graph tests the null hypothesis that residuals are white noise. Values above the significance level suggest no autocorrelation. Lastly, the Shapiro-Wilk test assesses the normality of residuals with a p-value of 0.004881, indicating that the residuals are not normally distributed, which might suggest room for model improvement. Forecast. This slide presents the ARIMA model's forecast for the defense budget along with the fitted values. The plot figure 7 shows historical data, the black lines, and the model fitted values, the red line, to the present with forecasted values extending into the future, shaded in blue. The shaded areas represent the confidence intervals, providing a range within which future values are expected to fall. The table below lists point forecasts along with their 80% and 90% interval, offering detailed insight into the expected future values of the defense budget. Thank you so much for your time and patience.